Hi, I'm here today with Lorien Rensing, and we're going to be talking about breaking down the monolith. So, welcome, Lorien. Thank you so much for coming on to talk with me.
Thanks, Michael. Very nice to be here.
So, go ahead and start by telling me a little about yourself.
I am a software developer at a company called Making Everlasting Memories. We focus on online memorializations, primarily targeting the funeral industry. So we build software as a service that allows the funeral home to basically store all of the data about the deceased loved ones for the family they serve. This would be the most obvious is the obituary. When you're a funeral home, they also can collect photos and videos of the decedent and also the messages that you might leave in an online guest book. And then they can use these to create meaningful keepsakes for the families they serve. So our job is to create a web-based software platform that makes that as easy as possible for the funeral directors. Their job is not to be software experts. That's our job. So we have
Yes.
a full stack based in C# and JavaScript primarily. We've got a little bit of Python and a little bit of Swift for some of our supporting applications, but mostly C# and JavaScript.
That sounds like a really interesting area to be in.
It
Uh,
really is, and it's not someplace you'd expect to find software. So it really shows that, yeah, this is everywhere now.
Absolutely. It's eating the world, some might say. So, I know we're here to talk about breaking down the monolith. So, why don't you tell me about what you started with, and then we can go from there to talk about how you made changes to solve problems.
So when I started at Making Everlasting Memories back in 2012, we had basically an online portal where you could log in and you could manage these life stories. And it was .NET with some JavaScript. It was all built in web forms, which in their day were great. And even
Absolutely.
by 2012, their day was sort of passing.
Pretty much, yeah.
And the other problem with this is the way everything was structured. We had a single sign-on project, and then all the other all of our other solutions sort of lived underneath that. So that made for some very interesting setups in IIS, but we didn't have to touch that too much.
Okay.
The other the other thing is we're using TeamCity for source control. So yes, you could check stuff out, but you couldn't really branch stuff like you can
Hmm.
with Git. So
Yeah.
that meant we got some interesting merge conflicts sometimes when we were trying to check our code back in.
I,
And
yeah.
then we also had the fact that at one point the idea was, well, if we've got all these common code, let's put it in a common project. And then all the solutions can reference that project, which sounds
Mhm.
great, up until you go to change something. So if you wanted to change something in that common code, you had to find everything that referenced it and test everything that referenced it. And the
Wow.
more common code there was, the more places you had to look. So people would just start writing new methods in this common code, which might or might not duplicate existing stuff, but at least you knew you weren't going to break anything that was already there.
That
And that,
reminds me a lot of
yeah, and that's
some
just
code that I've worked in the past.
when we were writing the code. Then when we went
Mhm.
to deploy the code, we had to deploy everything, whether it had changed or not, because you had all of this stuff that was so tightly coupled. You either deployed everything or you deployed nothing. So you had to be really careful that if you had code in flight, it either worked or it did not get checked back in.
That makes sense. Yeah. Did I'm so sorry, I lost my question. Um, so tell me about the first problem you set out to solve with this code base.
Well, the first problem was these deployments were really big and cumbersome. So we would come in usually between 5:30 and 6:30 every other Tuesday, and this was in
Nobody
the
wants to
morning.
do that.
This was 5:30 or 6:30 in the morning because we had a lot of customers in California who were more likely to be working evenings. So before work was the least disruptive time to do this.
Gotcha.
And even though we were in the cloud, we'd have to spin up new servers, we had scripts that would get run manually to back up the old code and upload the new code, and then we could start smoke testing things. And then we would have till about 7:30 to determine whether or not anything was horribly broken, because that gave us from like 7:30 to 8 to do a rollback if we needed to, which we did
Gotcha.
sometimes, because if
Yeah.
something wasn't working quite right or code that wasn't ready had accidentally been merged in, maybe because it was in a different project altogether than what we thought was going.
Wow.
So really, that was hard and it was painful, and we wanted to make it less painful.
Yeah. Generally, you want deployments to be as painless as possible.
Yeah, and these definitely were not painless.
Yes, I've had those before. You're just scared to deploy, right?
Yeah,
It becomes something you dread doing each week.
yeah. Or, you're worried about committing this code back into your main branch, because what if it breaks something unrelated, or
Hmm.
what if they find a bug and I don't have time to fix it before it gets deployed? Or alternately, well, I know this code is good and it's working, but it's 2 days before we're creating the new branch, and I know it's going to take me most of that time to move on to the next thing. What do I start working on right now?
Right. So, what was the first thing you did to start solving that problem?
Well, one of the first things we did was we decided to deal with all of these common shared projects that everything was referencing. So what we ended up doing was we started breaking these out into NuGet packages. So that meant that now, instead of all of the projects themselves being included in their parent solutions, we could just reference the NuGet package.
Okay.
If we needed to update some of that code, we could update the part we were going to update, but then only the solution that needed the update got the updated NuGet package. So you could
Okay.
make the testing a lot smaller and a lot more discrete. So all of a sudden, this big batch of code that was so tightly coupled together is now much more loosely coupled.
So, if you're saying you could bring those in different solutions, did you have multiple deployments at this point, or was it still one thing being deployed?
I think about the same time we were starting to figure out ways that we could deploy all of our projects separately, and decoupling was really the first step in that, because it was a common DLL that was referenced by all the projects, and as soon as that's not a common DLL, you don't have to deploy all the things at once. You can get away with only deploying what's changed, and that was huge.
Yeah, absolutely.
And then
So, go ahead. Sorry,
I
please.
was going to say the other thing we did at around the same time is we finally ditched TFS as our source control for once and for all. And like everybody else, up to and including Microsoft, we went with GitHub.
Nice. Good choice.
So that also meant it was a lot easier to handle our branching and merging, and it was a lot easier to have if multiple people needed to be working in the same part of the code. Say we're on a big project, there's a lot of us working in the same files. All of a sudden, merge conflicts get a lot easier to manage than they were when we were with TFS.
Yes, does give you a lot more versatility in that way, for sure. So, tell me about your testing at this point in time. Was it mostly manual? Was it more automated?
At the time I started, it was pretty exclusively manual.
Okay.
So we had a couple QA people. I think we generally had one person doing it full time, then maybe one person who was split between that and customer service. And then on the day of a deployment, anyone who had code going live was expected to be there, expected to give a once over of, at minimum, their code to make sure at least the happy path worked, and then help with testing other parts of the system, whether that was code somebody else had written or doing a manual regression testing of what were deemed to be basically critical parts of the system that had to keep working.
But there were still possibilities that you might
Yeah,
have affected something
yeah,
that you wouldn't
right.
expect.
Just in case something had carry-on effects that we weren't anticipating. And
Yeah.
yeah, It was all manual.
Okay. So was that the next step in the process as far as doing something about that, or what was the next step in your process there?
Part of the process was we added a build server to do, instead of having to run scripts to build all of the stuff, we started using a build server. The one we're using is called Team City.
Mm-hmm.
So that let us do a couple of things. So one is that it's got some integration points with GitHub. So
Mm-hmm.
first, we could require our code to build before you could merge a pull request.
Mm-hmm.
That was huge, because all of a sudden you're no longer checking out code and desperately hoping it will build and nobody screwed it up when they checked it in.
Right.
So the other thing it could do is it could run automated tests.
As part of the pipeline, I assume.
As basically to get a passing build, it could run these tests, and you could set a condition that unless all the tests pass, the build doesn't pass.
So what kind of tests were you running in that pipeline?
To start with, we were doing unit tests with NUnit. And the
Okay.
other thing that was happening at this time is we were moving away from web forms and creating some new projects using an MVC pattern.
Okay. Using ASP.NET MVC?
Some ASP.NET MVC, and then a little bit of an MVVM pattern, model view model
Mm-hmm.
with a JavaScript framework called Knockout. It was
Okay,
one
yeah.
of the earlier responsive frameworks.
Yeah.
So one of the downsides to being early and jumping on this single page app idea was we sort of had to guess what framework was going to be popular, and we guessed wrong.
Well, at that point in time, could you even have guessed something that would still be around now? It was.
I don't think we could have. I mean, we were working with some external consultants.
Mm-hmm.
They'd use Knockout, and as far as the data binding goes, it works very well. As far as event lifecycle, it's non-existent.
Okay.
And at the time, we didn't realize how much of that event handling we were going to come to need in the future. But
Gotcha.
it was a good place to start.
I mean, a lot of things have been built on Knockout. I think it was very popular for quite some time there. If I remember correctly, Azure Portal was built on that?
I'm not sure offhand. What it does very well.
Mm-hmm.
But it's also not being maintained and extended to get some of these lifecycle events that you're getting with Angular, with React, with Vue.
Mm-hmm. Which all of which the current versions weren't even around at that point in time.
Right.
So
you know, if we'd had Angular, I'd probably be talking about how terrible either it is that we're on Angular 1 or how hard it was to switch to Angular 2.
Right. If you want, we can continue on that path a little bit. Are you still with Knockout? Is that continue plan for the future?
We're still with Knockout. We're experimenting with some other frameworks. We've got one project that we have built using Vue instead.
Okay.
We're also talking about seeing, okay, now can we duplicate this in React? Can we duplicate this in Blazor?
Mm-hmm.
And you know, once we see all of these side by side, which makes the most sense for us to go with?
That's really cool that you're looking at Blazor. That's pretty interesting.
Yeah, and we're a very heavily C# shop, so and even with everything else we use, it still comes back to everyone's assumed to be able to do C#. So
that makes sense.
From that standpoint, sticking with Microsoft's offering, it would be pretty foolish of us not to at least look at it.
For sure. All right, so we've come to the point where you're running CI pipelines in Team City with some automated tests.
Yeah. And
what's the next?
And you
Go
know
ahead.
Stuff at this point mostly.
Okay.
In theory, you know, adding them at the beginning, we've had some consultants come in and teach us test-driven development. Occasionally, we even write the code that way.
Right. if we counted the number of people who have learned to write test-driven development and then actually do that on a regular basis, I think
I have occasionally written production code with test-driven development. I have more often done it the other way around, where I write the code and then write the tests.
Absolutely. Yes, I totally understand that. So you said you started using NUnit. Did you end up adding more other types of tests?
We did. So one thing that happened is as our QA department grew and became more focused on full-time QA and not having to double as customer service reps, is they started doing some automated tests with Selenium. So
Excellent.
that meant that a lot of this regression testing that we'd been having to help with every push day could be automated. You click a button, all of that runs in the background, and then the QA testers can focus on looking at what's changed.
Yeah, that so the Selenium test, and so excellent. So you added those Selenium tests. Um, did that lengthen your pipeline at all? Did that create any problems, or was it pretty
Well, we
manageable?
never really have found a way to get the Selenium tests working on the build server, and
Okay,
we still haven't. But one thing we eventually were able to do is working with some of our ops people was create a couple of dedicated virtual machines in our Amazon cloud environment. And basically each QA person has one that they can set up and run their scripts on every morning.
and so
So
you can. I'm sorry. Go ahead.
it's still kicked off manually, but
Mm-hmm.
it can happen really at any time you want to run these scripts.
So
And it
do your
doesn't mind.
QA people choose what to deploy to those servers? I assume they would just say, "Hey, I wanted this branch of the code on there." Or how do they do that?
So that came later, actually. So at
Okay,
this
my
point,
apologies.
we still have a problem of we've got 3 environments, but aside from the production environment, QA is not always sure what code is where. So we've got a dev environment, which is basically code that has just been written and you need to make sure runs on a real server, not just the developer's local machine.
Mm-hmm.
Then we've got a test environment, similar to, say, a staging or a release candidate environment.
Okay.
And then, of course, we have our production environment.
Excellent.
So in theory, QA was supposed to always be testing on the test environment, and developers were supposed to be giving everything a run through on the dev environment. But every now and then there would be something that would get a little bit weird and work differently in dev or test, especially if we were having to integrate with an outside system. Maybe that would only work on, say, the test and production environments and not the dev environment. So sometimes there would be the case of, well, I'm trying to test this, but I can't really test it until it's on the test environment, so let me just push up the code real fast. Or there would be the question of, well, when was code last pushed up to test? Because while the developers generally had access to the build server and could see what build had been most recently run or kick off a new build, QA at the time did not have that same access. So that was still a problem. So QA was really sort of had to run down, okay, what's really on the server right now?
They're
Is
kind
it?
of at the mercy of the developers.
Yeah,
And did you change? So it sounds like you've changed that at this
we have
point.
changed that. And it took a lot of looking into it. We actually went through a couple of other steps as a result of some long running projects that we had. So, we were trying to do a traditional, 2-week sprint pattern. You code for 2 weeks and you release the code and you have a retrospective and you iterate over that process. But the problem
Mm-hmm.
is the real world doesn't work in 2-week sprints.
It's true.
Sometimes you have a bug fix that takes you 2 days. And sometimes you're adding a huge new feature that takes you 2 months. So you've got this problem of, well, how do we test this 2-month feature? We can't test it. If we wait till the end, it's going to take us another 2 months to test. So now all of a sudden your 2-month feature has become a 4-month feature.
Mm-hmm.
Or we can push part of it up to the test branch and you can test the part of it that's up there, but you can't release it because it's not done yet.
And that
And
could hold up your release. And
yeah, and then this 2-day bug fix, what happens to it?
it gets
That
caught behind
it
that big
gets caught behind
feature.
the big feature, yeah.
So how
So
did you deal with that?
initially, badly.
Okay.
We had
Like
some code,
everything, right? Like
yeah, we either had
we
some,
fail first.
yeah, we had some code that got held up behind these 2-month features, or we would try to do it as, low to medium priority bug fixes that, could have gone out every 2 weeks with no real impact. We were doing them as basically as hot fixes on production.
You
These
kind of
were not,
deploy the code direct.
yeah, and these were not things that normally would have had the priority to be a hot fix.
Mm-hmm.
But that was really the only way to get things up. So that was a problem. So we ended up basically restructuring our entire deployment pipeline and giving QA a lot more of the keys to how code got onto this test environment.
Excellent.
So we ended up writing some new deployment scripts. So instead of just, okay, take what's on the test branch and deploy it to test, or take what's on the dev branch and deploy it to dev and deploy it to test, we actually created new scripts that would look for a branch called test / and then a release number.
Okay.
And the only people authorized to create these test branches were QA. So
Good
regular
call.
developers could not create a test branch.
Because developers want their code out.
Right.
And QA wants to make sure that it works.
And QA they want to know what they're testing.
Yes.
So this is where having the 3 environments helped. So developers could still push their code to the dev branch whenever they wanted. QA, meanwhile, would pick a date to create this test branch. They would push it up there, and they knew what was in that branch. So they knew what they were testing and could say, okay, this is what we're releasing. This is what we've tested. Or alternately, this isn't working. We're not releasing this. Fix it, and we'll create a new branch and test it again.
Excellent. Do you have any issues where do you cut release branches, or how do you deal with that? And you just said you did, and then you would make a commit onto that release branch, I assume?
Yeah. There's a couple different ways we do it depending on how urgent it is. Sometimes we will open a pull request against the existing branch. Occasionally things will just be so bad, or there will be so many changes that they found that they'll just say, no, we're not releasing this branch. Wait a week, wait 3 days, we'll cut a new branch and start over.
Gotcha.
So, with our system where we don't have to release every solution every time, we have the flexibility to do that, because when QA cuts their branches, they cut their branches per solution.
Oh, great.
So they're only adding the new code that has changed and in theory will be released to production.
Excellent. So what was the next step in the process of the breaking down the monolith?
Oh, let's see. So we've got our.
I think we've ranged around, so I know it's not been really direct, but
was we're trying to automate a lot of this stuff. So one of the other things we did was we can still manually deploy a branch to our test environment, but we actually set it up so that once that latest pull request has been merged into our dev branch and has been built on that dev branch, we've actually set up a continuous deployment on that dev environment. So basically within, say, 10 minutes of committing, and that's for our largest solution that has something like 5,000 unit tests it has to run after it builds everything. In that time, it can merge, build, and deploy up to the test environment.
Excellent. So you're getting that continuous deployment to the test environment at least.
Yeah, the dev environment.
My apologies.
So the developers can very quickly see what things look like and see that it doesn't just work on local, which is a phrase that makes management's head explode when you tell them, but it worked on my machine.
Right. Get one of those works on my machine stickers.
Yes.
Excellent. So you've got your code deploying to dev and test environments. You've got QA able to handle that process, and you're able to cut release branches and release those to production in a more rigorous manner. What kind of problems were you encountering at that point?
Well, we were still running into the issues with we're still finding bugs in production. So at this point, we decided to start and apply some data to it. And let's face it, we're in this job because we like data. We generally like numbers in some point.
Yes.
So one of my coworkers started a spreadsheet and he was tracking how many days has it been since our last release? and how many bugs did we find? And we've actually got some really nice graphs showing a very nice matching trend that indicates the more time we took between releases, the more bugs we found.
Almost linear, basically.
Yeah, and you've got these things where you've basically got two sets of nice jagged graphs, and they're just parallel to each other the whole way through.
Right.
So we started thinking, well, why do we have to wait 2 months to deploy code? Why do we even have to wait 2 weeks to deploy code? You know, some of these we've been deploying in 2 days because we had so many bugs to fix. And then the second
Mhm.
deployment, you know, we find one bug or no bugs. Why can't we do that all the time?
Mhm.
And the answer to that at the time was, well, what if we've got code that's being worked on that isn't finished?
Mm.
Which is a valid concern.
Because it's
So
already a master, essentially.
yeah, it once it's committed, it goes up, whether it's
Mhm.
done or not. So we started trying to find a way, well, what if it could go up and you couldn't see the code? What if that code just didn't run? So we built our own toggling system, and it's basically just a database. It's got an on or off Boolean, it's got a key, and it's got a descriptive name. And so now any of the code that might not be done, might not be fully tested, you wrap in this toggle, you leave the old code outside the toggle, and as long as that toggle is turned off, then this half-finished code can be safely in production.
So you have a database for each environment, I assume, correct?
Yes.
And then so you just change those toggles by changing the database for that environment.
Yes, and we actually set up a page so we didn't have to go in and run a script every time we wanted to turn a toggle on or off.
Right.
It just goes and does that for us, so it's really easy to see what's turned on and what's turned off.
Excellent. And then I assume each developer, do developers work off a central database, or do they each have a database on their machine? How do
We
you use
work
that?
off a central database. This is an artifact of that system as it was when I originally came. They had a very elegant textbook third normal form database holding an awful lot of data because they serve an awful lot of funeral homes who serve a lot of families. There's a lot of pictures, a lot of obituaries.
A lot of valuable data.
There is a lot of valuable data, and this was textbook third normal form. And that textbook was probably about the size of the Oxford English Dictionary, which I've seen in person once. It's like 6 feet long.
Oh my goodness.
Yeah.
Yes.
So it's not really feasible to have a local copy of that database.
Gotcha.
So we've got one for each environment. We have SSIS packages to keep common data flowing nicely through the environments and making sure things don't get missed, or half of the data gets moved and the other half still has nulls or default values.
Yeah.
And
Don't
we've
want to see
got
that happen.
so we've got some structure around this, but we don't have our local copies.
Gotcha. So the SSIS packages are moving the configuration data between
Right.
environments.
Right. We
Okay.
finally actually added one for these toggles I was just talking about to bring it
Nice.
back to that. So you can create your toggle on the dev environment, and then it will flow through the other environments. It will automatically turn the toggle off on the test and production environments, but it will keep
Nice.
a consistent key across environments.
Excellent. And so those toggles, do they affect your back end and front end, or just the back end?
They affect both the back end and the front end.
Okay.
So depending on what we need. So for instance, on the back end, we might process, say, how do you save this object? And if we're coming up with a new data structure, we might say, well, if the toggle is turned off, save it to the old data structure. If the toggle is turned on, save it to the new data structure.
Gotcha.
On the front end, it might be like, okay, we want to add this new control to our page. If the toggle is turned on, make the control visible and populate it with this data. If the toggle is turned off, don't render it on the page.
That's great. That gives you full control over your full environment. That's great.
Yeah. So it means, one, there's a lot lower chance of code ending up in production and active in production that shouldn't be. And it also means that if for some reason a project has to be paused, with all that code behind a toggle, you just leave the toggle off for as long as the project is paused and then can pick it back up eventually when it becomes active again.
I imagine that also makes it very easy to turn off features in production if they go bad.
Yes.
That's a fantastic benefit, I imagine. If
Yeah, it's not perfect. We've got some things that are strictly database driven. So with those we do generally have to have very specific scripts to handle.
Mhm.
But there's a lot fewer things that have to be done with manual database changes now.
So tell me a little bit about that with the database. How do you handle things like schema and data and changes and migrations and stuff like that?
A lot of it is still fairly manual.
Okay.
We have started breaking down our database in a couple ways. When I started here, we had one schema. It was called core.
Okay.
And
It's the core of everything, and
yeah.
it is everything.
And then we started adding new schemas to be more descriptive. What does this sort of data refer to?
Gotcha.
And that was nice, but it was all still in one database.
Mm-hmm.
So it's a little closer, excuse me, to our domain model now, but it's still one database. It's still pretty normalized.
Okay.
So then we started adding additional databases so that each database only handles a specific feature.
Nice.
And it has, all of its type tables and reference data in one database. And it stores any of the individual choices that you've made, say for a story that uses this feature, all go in this database.
So did you start by doing that mostly for new features, or was that breaking features off and moving them into separate databases?
It was a little of both.
Okay.
So, like I said, we started in web forms and we've moved more to an MVC, MVVM single page app model. And we didn't move everything at once.
Mm-hmm.
Some people actually managed to figure out a fairly clever way of making them coexist so that you could actually show the web forms within the single page app.
Wow, that's
Yeah,
impressive.
it's very impressive. There was a couple months where all we did was try and get like 2 features in and then make everything else display properly. So that also means that we've been able to move features one at a time into this new pattern. And so what would happen is we would uplift a feature and then at the same time we'd give it its own database.
Nice.
So it was all working together so that all the new code went to the new database.
And so when you would split those off, did you do like a one-time migration of the data into that new database?
The interesting thing is with a lot of the features we were migrating, we had not actually saved a lot of the user data. So that was one of the things that was really requested by our customers is, well, I've used this feature to generate a printable keepsake and the family wants some more of these, some more, say, prayer cards.
Mm-hmm.
Now I don't want to have to go back and make all of these choices again.
Mm-hmm.
Can I save this somewhere?
Nice.
So that was one of the things we would add in these uplifts was the ability to save this. So now instead of having, a table in the main database for this, for each feature, or worse yet, one table for all the features, which we might have done in the old model, or say 5 tables in the old database, trying to save everything in this very normalized
Right.
fashion
This
that
piece,
didn't actually, it was not at all intuitive.
it wasn't adding value, probably.
Yeah, it
It,
really
it,
wasn't.
it was it was pursuing that form, but it wasn't actually making
It
it
was not
easier
adding,
to build
yeah,
or
it was not
develop.
adding value. It was not a domain-driven model at all.
Okay, that makes a lot of
And
sense.
so we've been, instead of going for a third normal form and trying to make the business fit into that, we've been, with these new databases, we've been trying to make the data structure match the business logic. And yes, there's more duplicated data now, but it's much more understandable. you don't have to go through, say, 5 tables to get all of the data that describes where to find one image.
Okay, that's good to know. And so
Yeah.
you were talking about the duplication. Is that something where you've had to add in constraints to make sure that you don't get bad data in there, or was it more just a factor of we don't have to store the state Ohio in one single place?
A lot of it's, for instance, with, like I said, with the images being in 5 different tables. So we might have, say, a common media table that would have things that any piece of media would have, whether that's audio or video or an image, which would be,
Mm-hmm.
say, a URL to where the file is located.
Gotcha.
And then you'd have, say, an image table that might give you the dimensions of that image.
Okay.
But the video
Wow.
table might give you the length of the video.
So now you had in the past you had to join all of those tables together
Right.
to get the
Whereas
image
now
about
we
the
can
interested.
say, whereas now we haven't done this, we're only starting this with images, but the goal is to have an image table that tells you everything you need to know about an image in one table. And if it means that there is a URL column on the video table and a URL column on the images table, that's fine.
Just okay.
Yeah.
That makes a lot of
We're
sense.
okay with that now.
Absolutely. Good call. So, okay, so we're starting to split off databases, we're splitting off features, we've got this really cool way to bring web forms into Knockout, right? Is that,
Yes.
and what kind of problems do you start encountering now, or what problems do you have that you now want to solve?
So one of the first problems we had to solve when we were learning to use GitHub is how do you make sure that the right stuff is on the right branch? Because at first it was
Okay.
like, okay, I check out code, I pull it down to my local computer, I push it back up, which when you're working on your own branch is great.
Mm-hmm.
And when you make the changes directly on this dev branch and then push those back up, and somebody else has just made a pull request into the dev branch, you've just overwritten their changes.
Oh no.
And this happened. Now, fortunately, this was not our master branch, which we did have locked down because we wanted to have something that was basically, here's what we know is on production.
Mm-hmm.
Yes, we have backups. Yes, we have AMIs that we can spin back up. But just in case, we want to have that repository and know it's there.
Absolutely. You don't want to have to go to those backups.
But we had a dev branch that was unlocked because we needed to be able to get our working code back into it.
Mm-hmm.
And it was completely unlocked, which meant that you could push directly to that branch.
Oh my.
And somebody did. And the rest of us in the office lost about 2 hours of work.
I am sorry to hear that.
Yeah, we were able to get most of it back. And the parts we didn't get back, I think people still had local copies of.
That's the beauty of Git, right?
Yes. As long as you haven't deleted that local branch, you can pull it back up.
Cool. That definitely a big benefit there.
Yeah. So at that point, we locked down our dev branch. So we now require a couple of things to get code into there. One, you have to open a pull request.
Mm-hmm.
2, the pull request has to be reviewed by a developer. And it can't be the developer who opened the pull request. It has to be someone else.
Good call. I think my code looks good.
Yes. And we don't really have a good way to enforce this, but if you've been pairing with somebody else, the convention is ask a third developer to review it.
Good call. Do you do a lot of pairing?
It's one of our more common ways of training new hires. So
Excellent.
that's one of the things that I do a lot of. So it's not uncommon for me to be pairing with a more junior developer. They'll open a pull request. And we've actually got a Slack channel now that pops up a message as soon as a pull request has been opened, which is really useful for keeping those from hanging out and getting stale. But it's not uncommon when a new developer opens one of those for me to put in a comment saying, can somebody else review this? I was pairing with them on it.
Do you review a lot of them is what I'm hearing?
I do.
Okay.
And that's a lot of that is, how long have you been around? What are you used to seeing? So.
Gotcha. That makes sense.
So you have to have the approved pull request. We also, with the Team City, your code has to build. So it has to compile and it has to pass all of the unit tests. We've got a couple projects in .NET Core. We've added some front-end testing using Nightwatch. And unlike
Oh,
Selenium, we have been able to get Nightwatch to run on our build server.
tell me about what is Nightwatch? I think I've heard the name, but I don't know much about it.
I don't know a lot about it either. These tests have all been written by our QA team, but it is
Okay.
basically the front-end testing framework that
Okay.
they're using.
So kind of like Selenium or Cypress.
Yeah, kind of like that, I think, but I couldn't say for sure.
Okay. Cool. So you've now got some functional tests running on your .NET Core.
Yes,
Is that helping you to catch a lot of bugs as well?
I think so.
Okay.
And it's also identifying, okay, stuff has changed. Let's take a quick look at it, run through it manually and see, okay, yes, it is supposed to be doing this. Let's now get these tests updated to match.
These are the changes we expect.
Yes. Yes, this is broken, but it's broken the right way. So,
Yes, I meant to break that test.
yes. Yes, we
Uh,
knew we were changing this. This test should fail here.
Excellent. So where does that bring us now? Is there a next step in this process? Is there where are we at?
So we're doing pretty well. I think it was the end of 2018. In December, we hit 100 code deployments that year.
That's great.
We started tracking these numbers in 2000. I'm trying to think. Yeah, it's 2017. We started doing our tracking of deployments versus bugs found. 2018, we started, instead of deploying every 2 weeks, we started being able to deploy twice a week. So we were deploying a lot less code each time, but that also meant there were a lot fewer places for bugs to creep in. So we were delivering more value, and the value was higher quality.
Mm-hmm. Did you find that it was easier to find those bugs or find the source of those bugs once they got deployed?
I think so, because there's fewer places that it could be.
Mm-hmm.
Now, it doesn't always happen. I'm working on one right now that turns out has probably been in place since 2016, but wasn't hurting anything until September of this year.
You kind of moved something which uncovered it.
Yeah, basically.
Okay.
So
Yeah, those are definitely insidious in a way. It's like I didn't change anything there.
yeah,
Why
it's
is
like
this
I didn't
breaking
change
now?
anything, and okay, no, I wasn't working on this. Somebody else was, but I know what they were working on because I was working on something related to that, and I know they didn't change anything. And just to prove it, I will go and hit the blame button, and I will show you that this code has not been touched since 2016.
Wow. Why?
Yeah.
And you always wonder. You're like, should we have caught this before? But then you realize
Yeah,
that
and
it
then
was
you
just
realize
something that was.
why it wasn't caught. It's like, okay, it didn't hurt anything before,
Mhm.
and now it does.
It's those subtle tweaks.
Yeah.
So okay, so you're saying you're at the end of 2018 and you're deploying about 100 times.
Yeah,
You were able to deploy 100 times that year, which
yeah,
is
I think it
great.
came up to like this was at like the beginning of December. We hit 100. We had a party for the whole office. In the presentation that goes with this interview, there's actually a picture somebody took of the number 100 spelled out in donuts.
That's fantastic.
I think by the end of the year, we'd hit 104 deployments.
Excellent.
And
And the other nice thing about that is you're delivering value to the customer faster, right?
yes. So we don't have any of these, okay, it's going to take me 2 days to make this change. It can go up anytime in the next 2 weeks, but I've got a long running project that's going to take 2 months. Do I wait 2 months or do I do a hot fix? Now
Right.
it's just, okay, you found this on Wednesday. Okay, we can get it on the test branch on Thursday and go to production on Tuesday.
That's a lot faster turnaround.
Yeah.
So, okay, so what's the next step in the evolution here?
We'd really like to get these databases slimmed down. Like I said, there's still some parts of it that are like the images that are highly normalized that we're only just starting to break apart because we use images in a lot of places in our system. So that one would require a big migration. We want to make sure we do it right because unlike our code, we don't have a source control where we can just go and, give me the changes since Thursday. We have backups, but to run a backup on a database at this scale takes a while.
I can imagine, yes.
Yeah.
Do you have plans so you've got plans to modify, migrate some of those tables, and I assume you're saying you don't have them under source control yet, but you plan on doing that?
Right. We've started moving things like our SSIS packages are under source control. We'd like to get, say, some of our, at least the schemas and the structures of those tables under source control, so that we could, regenerate at least the table structures faster instead of having to build an entirely new database from backups.
Yes. Good call.
And if we could get some of these things smaller, then conceivably a developer could have a local version of the database on their own computer. We wouldn't be reliant on always connecting to one of our existing databases, which is usually the one connected to our dev environment.
That's a big step, especially when you're making those database changes. You have to coordinate, right? So you'd say, I'm going to make this schema migration on the dev environment.
Right. So, or you can say, well, I need to add this new column to the database, and I'm going to then put that property on the corresponding entity, and I'm going to start accessing that property, but only behind the toggle. But because we're using Entity Framework and it's got some very convenient auto mapping built in right up until you forget to add that column on the table in the database.
Then it's not so happy about it.
And then it gets very unhappy because you can't put that kind of mapping behind a toggle.
Right. So true. So tell me about, were there any points in the process where you got into any kind of analysis paralysis? Like, we want to make a change, we want to fix this, but we're not sure how to do that?
I think so. And one of those was in the very beginning when we were trying to move away from web forms. It's like, well, we can't just stop and rewrite the whole thing. The whole thing's already huge.
Right. It's valuable. It's helping customers.
People are using this every day. We can't just say, okay, we're not going to add any new functionality or fix anything that breaks for 2 years, and then we'll give you something brand new that looks nothing like what you've ever seen before. So there was a lot of, okay, well, how do we even do this? And then there's also, whenever we're trying to decide, okay, yes, we really are going to go to these new databases, figuring out, okay, well, what really needs to be moved into a feature database and what can stay in our core database? Because say, we might have a catalog of, say, different styles of paper that you could print something on. Do we want to have one common catalog? Because a lot of this stuff, you might have it for a prayer card, but you might also have it for a bookmark. Do we keep that style table in our main core database, or do we put it in the feature database? So there was a lot of looking at, okay, how much of this stuff really is held in common and how much of it is specific to the feature. And for that, we came up to, there's enough of it that's specific to each feature. Let's put it in the feature database. And yes, maybe that means each feature database has its own style table, but it's a style table that matches the business logic of what we need for that feature. But trying to figure out just how are we going to do this? There's a lot of thinking of that. And then we also run into it when you're going in and looking at code we wrote, not just the web forms code, but even some of our earlier attempts with Entity Framework, and going through and going, okay, I know I wrote that. I know I had a good reason at the time. I'm sure that there's a better way to do this.
Because what I'm looking at right now.
And that would be my week to date.
So, yeah, so you kind of talked about When we've now talked about encountering some of that code where you're like, what was whoever wrote this, what were they thinking? Of course you can try to blame, but sometimes that doesn't help you much, especially
Yeah.
if the person is left or it's you and you
Yeah.
have no idea what you were thinking.
Yeah. In my case, I do keep notes, so I was able to go back and figure out about half of what I was thinking. The other half, I'm still not sure.
Did you ever have a desire to like burn it down and start over?
Oh yeah.
Okay.
Oh
And
yeah. There have been some things. There was one feature we had removed some functionality from to integrate with some third-party software. There was a business decision made that the third-party software wasn't providing us with enough value, so we were going to put the functionality back. But we cleaned it all up very nicely, so it wasn't just a matter of uncommenting code. It was, what did this used to do? How do I make
right.
it do that again? And I was working on that project, and as it was getting finished, I told the person who was likely to be using this, please complain about this. If you complain about it enough, they might let us rewrite it.
Yes. That's a good,
It's an internal tool, so
okay.
they tend to be prioritized lower than customer-facing stuff.
So actually, that brings up a good question. Are there things that you've specifically done to improve developer experience to make it easier to develop? I know you've mentioned a lot of stuff already. Are there any other things like internal tools or command line applications that you've built to make it easier for developer experience?
We try to automate stuff wherever we can.
Mm-hmm.
So some of these are like plugins for Visual Studio. We've got one called Format on Save. So it does
Nice.
things like it lines up all of your curly braces. It gets rid of all of your unused using statements and then alphabetizes what's left. It normalizes your line if you do or don't want a line break at the end of your file.
So yeah, there's things that computers are really good at, and we should probably just let them do those things.
Exactly. So we use that. We've subscribed to a plugin called ReSharper that adds a whole lot of really convenient shortcuts for setting up an awful lot of things and, automatic refactoring, things like that. So,
I am a huge fan of ReSharper. It's fantastic. I've used it in the past, and I love it a lot.
oh yeah, it is worth the trade-offs, I think, on that. So,
So go ahead. Sorry.
yeah, basically just trying to, if it can be automated, we're trying to automate it. So also things like, letting there be an integration between our GitHub and a Slack channel to tell us, hey, there's a pull request open.
That makes a big difference because otherwise it languishes, or else you have to ping people or
And
something
hope
like that.
somebody's there. Yeah.
So I was going to ask, do you feel like there were any mistakes made along the way? And and are there ways that you've tried to avoid those mistakes?
I think there are. So one of the things, for instance, when we were using GitHub and we were using branches but before we were using the toggles and we would have these 2 month features, on the one hand, it's probably better for development to make sure that, okay, we've got this long running feature. Let's get it done. Let's get it right. Let's get it tested as we go, which was great, except it tied up our our test environment,
Mm-hmm.
and it blocked all of these smaller bug fixes and smaller feature enhancements that also needed
Mm-hmm.
to be tested and also needed to go to production.
Mm-hmm.
So that was definitely a mistake doing things that way. But I think if we hadn't made that mistake, then we wouldn't have been motivated necessarily to find a better way.
Which was the toggles.
Which was the toggles, which was the twice weekly deployments on a regular
Mm-hmm.
schedule. Another thing is when we started moving to this twice weekly schedule with the toggles, there was figuring out, well, exactly how do we test this? Because at first QA was testing with all of the toggles turned on, making sure all the new code worked even if it wasn't going to production, and then they'd run out of time to test code that was going live. So we looked at that and said, well, what if we test with the toggles turned
Mm-hmm.
off first?
Mm-hmm.
Then we get the production ready stuff done. Stuff that's not going live, you get as far as you can. If it's not fully tested, that's okay. It's not going to be visible in production anyway.
You get the most important confirmations first.
Right. So, and
That makes a lot of sense.
one of the things we figured out was we actually took a page from the sprint things, even though we weren't doing 2-week sprints anymore, we actually would have retrospectives with all the developers and everyone in ops and everyone in QA to see, okay, is this working for us? What are our pain points? What can we do to make this better?
And it's great that you brought everyone in together, not just developers, but you brought in the QA, you brought in ops.
Yeah, and this was because deployment really did involve all of these people. And occasionally we'd even bring in, depending on what had happened that had been painful, we might even bring in, say, graphic design and communications. For instance, are we releasing too fast? Do we need to notify our customers better? And that would be communications. Do we need to move new graphic assets up? Is there a way we can communicate that?
Mm-hmm. That's great. So sorry, I lost my train of thought. I apologize. Thank you. What else? Anything else you'd like to tell me about some of the work that you've done to modernize? And I remember my question. Are you still doing manual deployments, or has that been automated as well?
A lot of it has been automated. And we're working on both further automating it and making our deployments to our test environment more closely match the deployments to our production environment.
Excellent.
So we are in Amazon, the Amazon cloud.
Mm-hmm.
So we can create AMIs, Amazon machine instances, and we can
Mm-hmm.
version them. And at some point we realized that, okay, we don't actually have to create our new gold instance right before a push. We can create it several days before.
Mm.
Or we can create it the night before.
Mm-hmm.
And after trial and error, we basically figured out, okay, the night before is the right time to create these machine instances.
That way you're not paying for it any longer than you really have to.
Even if it's spun down.
Mm-hmm.
Yeah, and the other thing is that if we do have to do a fix for something that was on the test branch, we don't have to recreate that AMI for the next push.
Okay.
If we're pushing code on Thursday, we think we've got everything tested Wednesday morning, we create the AMI. Wednesday afternoon, we find a bug. Oh no, okay, we've got it fixed, but now we need new AMIs.
Okay.
Create it Wednesday night.
You don't have to go back.
Yeah, we're pretty solid on it.
That's good.
So we've been able to create a lot more scripts to automate the deployment. We can spin up new servers and grab from the most recent AMI, spin down the old servers to the original number. It takes out the oldest ones, and now all of our servers have the latest code on them. So scripts to do that automatically.
That's great. So I know I've had you almost out here almost an hour, and I do want to respect your time. Is there anything else you want to specifically call out, and anything you want to talk about before we kind of wind this up?
I think the big thing is, it really is something that can be done, but it's sort of, how do you eat an elephant?
Right.
One bite at a time. And it doesn't have to be a big bite, so you find one improvement and find where, then you can go back and take a look at what you did. Did it make things better for you? Did it make things worse for you? If it made things worse and didn't make things better, can you just go back and start again? If it made some things better and made other things worse, well, those things it made worse, how can you improve that?
Right.
If most things are better, well, what's your next pain point? How do you make that better? So basically, if, like so many people, you're coming from an existing system and you don't have the option of, well, just put everything in your Docker container and move it between environments.
Right.
That's great for greenfield development.
Mm-hmm.
Don't want to knock it for that, but it's, when it's not an option because you've already got this monolith,
Mm-hmm.
you don't have to break it down all at once. You can take it apart piece by piece.
And continue delivering value along the way.
Right. You don't need to try and do it all at once.
That's really good advice. Thank you.
You're welcome.
So thank you so much for joining me, Lorien. Is there anywhere that people should follow you or contact you if they're curious about some of your experiences here and want some advice or anything like that?
I am on LinkedIn. I am even occasionally on Twitter.
Okay.
Right now, I'm sort of on a Twitter ban, being political season.
That's totally fair.
I make no promises that I will respond quickly, but I am Maker Lorien on both Twitter and GitHub.
Excellent. Cool. I just want to say thank you again so much for talking with me today. I've learned a lot about really improving the monolith, making it easier to work with. And it's always good to hear about people's processes for making their code better, making their deployment process better. So
thank you very much for having me, Michael.
Cool. Thank you, everybody, and take care.